Welcome everyone. In this video lecture, we will solve a GATE 2015 question in which we have to find the frequency and condition of oscillation in an open-based circuitry. So the question is, the circuit shown in figure has an ideal open. So this one is an ideal open. So we have to find the oscillation frequency and condition to sustain the oscillation frequency, and these are the options. So this one is the circuit. So this one is an oscillator. So we have to first take care of the Parkinson criteria. So I am writing here Parkinson criteria. For oscillator, the Parkinson criteria will be A beta will be 1 and the angle A beta will be 0 degree or 360 degree. So we have to use this concept to solve this problem. So in such problem, first of all, we can see the feedback network. Okay. So here we can easily say the feedback network is this portion. Okay. This one is our feedback network. Okay. So this one is our feedback network. Okay. And again, in that feedback network, I am assuming these one and another one more combination of C and R edge. Say this one, I am just saying this as a Z1, Z1, and this one I am saying as a Z2 impedance. Some impedance will be there. So Z1 and Z2. So if we think the Z1 value, if you think about the Z1, Z1 is nothing but simply R parallel with the 1 by 2 CS. Okay, so R1 is clear. Z1 R parallel with 1 by 2 SC or 2CS, anything you can write. And the value of Z2 will be our 1 by SC, that is the impedance of the capacitor, plus 2R because it is in the series. Okay, so one can solve this one easily. We can solve this one. So we have to solve R into 1 by 2 SC divided by R plus 1 by 2 SC. So if we solve the for the Z1 part, it should be R by 2 SCR plus 1, and for the Z2 it should be our 1 plus 2 SCR by SC. Okay. So once again I am just putting all this thing in a rectangle. Means this one is our Z2 and this one is our Z1. Okay. This one is our Z1. Okay. Why I am writing this one? It is very simple fact that if we write in terms of this one is our Z1. Okay. So Z1 is there, Z2 is there. Now our circuit will look very simple. Okay. If we again redraw the same circuit, suppose why I have made these two calculation, it will be quite easier to think. Suppose the same figure, I am just okay. Means why we have to take care of this Z1, Z2 in solving such type of problem, R1, R2. Then we can assume this one is some resistance type of thing. So this one is our say Z2. Okay, their value is given and Z1. Okay, the same circuit we have modified. Clear? Now what we have to think, this one is the feedback network. This one. This one is our feedback network and the other one is a amplifier network. So this voltage we can say our Vf. Yes or no? Simply this voltage is our Vf and this value is our Vout. All are Vout. So we can easily find the value of the feedback voltage Vf. So the value of feedback voltage Vf can be written as Vf equals to what? V out. Just we have to use the simple concept V out into Z1 by Z1 plus Z2. Okay, simple voltage division rule. Suppose for the timing, just I am giving one more example for this one. I am just saying this one is our V out, okay, and this one is R1 and R2 resistance, and we are giving some voltage say V in, okay. So the V output value will be R2 times of V in by R1 plus R2. The same concept we have used here, okay. The same type of concept is used for this circuit, okay, for this VA. Clear? So this is VF. Okay. So now as we know the feedback gain of the amplifier, that is our VF by V out. The feedback gain is denoted by beta, is nothing but simply VF by V out. So I'm not going to the theory, okay, but beta value, the feedback gain, the feedback network have some gain, say beta. So this beta will be our Vf by V naught. So Vf by V naught is nothing but simply our Z1 by Z1 plus Z2 in the denominator. Okay. So this value we have already calculated. So Z1, Z2 known to us. So now we have to do some calculation for the beta. So that beta value, Z1 value is given R by 2 SCR plus 1. Okay. Then after Z1 plus Z2. So again we have to write R by 2 SCR plus 1 here. Okay. Then plus Z2 value. Z2 value is also given 1 plus 2 SCR by C. Okay, now we have to solve this one. Okay, so how we have to solve? Okay, we have to go a step by step. 2 SCR plus 1 I am writing in that form. Okay, then SCR we have to put here, then 1 plus 2 SCR, okay, whole square divided by 2 SCR plus 1 into SC. Okay, so this one and this one will be cancelled out. In the numerator it should be SCR divided by SCR plus the whole term. So once again I am writing 1 plus 2 SCR whole square. Okay, now again we have to solve SCR. Now we have to break the denominator section. SCR plus 1 plus 4, this one is our 4, S square C square R square plus 4 SCR. Okay, because in most of in such problem we can easily find by equating the imaginary part to 0 will give the condition of oscillation. So, but we have to find this beta. Right? So, this beta value will be SCR divided by what we can write 4 S square C square R square plus 5 SCR, okay, plus 1. Okay, so this one is the value of beta. Okay, beta value we have calculated. So I am highlighting this one. So because this one is a important result, so I am highlighting because bar consent criteria. So we have to find beta and the amplifier gain. Okay, so now we have to find the value of a amplifier gain. Okay, so this voltage is simply our VF. You can say now this voltage is VF. Okay, so we have to find the value of amplifier gain. So the amplifier gain, the A value will be this one is nothing but simply non-inverting amplifier. Non-inverting. If we are taking this as a VF, I'm just making one more diagram, and I am saying this one if I am considering VF and this one HR2 and this one HR1. Okay, so V output by VF is nothing but simply our 1 plus R1 by R2. RF by R1, it should be R1 by R2. Okay, so this one is just non-inverting amplifier. Just think about the non-inverting amplifier. Okay, this one is also our very important result. So I am again highlighting. Okay, now A is known to us, B is known to us. Okay, so now multiply A beta because in oscillator we have to think about the Barkhansen criteria. So the loop gain 1, so better to find A beta value first. In any problem we have to find the value of A into beta. So now the value of A beta we have to calculate. So what we have to do, just write A and beta and multiply A with beta. So it should be our 1 plus R1 by R2 into SCR by 4 S square C square R square plus 5 SCR plus 1. Okay. Now we have to solve. Okay. So how to solve this one? It is very easy. So what we can do? One can do 1 plus R1 by R2. Okay, then if we take SCR common in the numerator and denominator, okay, I am just taking SCR the, okay, then SCR again I am taking common, so it should be our 4 SCR plus we can write 1 by SCR plus 5. Okay, so this and this will be cancelled out. Again I am writing 1 plus R1 by R2 into then SCR. Suppose now here we can put S equals to j omega because we have to find out the value of frequency. So S equals to j omega we have to put. So now one can write 1 by 4 SCR. So 4 RC into j omega plus 1 by RC into j omega plus 5. Okay, now again, now here I am writing 1 plus R1 by R2. Okay, 1 plus R1 by R2 into 1 divided by we can write this as a j omega for RC. Okay, then we can multiply j at the, what we can say here. So one can write j by j square omega RC plus 5. We can write, just we have to find the value of a beta. Okay, then we can easily identify the oscillation frequency of oscillation. Now j square is minus 1, so one can write 1 by j omega 4 RC minus j square minus 1, so it should be minus j by omega RC. Okay, I am writing step by step. Okay, plus 1. Okay, this one is clear. So now this one is one expression. Okay, so now for the frequency of oscillation, I am here writing for frequency of oscillation. Okay, frequency of oscillation, we have to take the imaginary part to 0. So before that, I will write one more line, 1 plus R1 by R2 into 1 by 5 plus J omega for RC minus 1 by omega RC. Okay, again I am highlighting this, because this one is important. Okay, so in this one, for the frequency of oscillation, we have to make the imaginary part to 0. Make the imaginary part to 0. Okay, make the imaginary part to 0, or we can say equate the imaginary part to 0, or we can say simply say equate the imaginary part to 0. Okay, so the our imaginary part is omega 4 RC minus 1 by omega RC equals to 0. Okay, so we can write omega 4 RC equals to 1 by omega RC. Then we can write omega square equals to 1 by 4 R square C square. So omega value will be 1 by 2 RC. Okay, so this one is the frequency of oscillations. Okay, if we have to write in terms of f, so we have to write 1 by 2 per RC. Okay, so this one is the way to find the frequency of oscillation. Okay, now again we have to find the condition of oscillation. So for the condition of oscillation, I am writing condition of oscillation. Okay, so for the condition of oscillation, there are two conditions. One is A beta equals to 1. So we have used the concept A beta 1, and then the angle will be 0 degree. So we can say the tan inverse of this upper section minus this lower section will be come to 0. Okay, if this one is A beta, this one is our what, A beta. So the angle for this one will be tan inverse 1 plus j0, we can write in the what, upper section, in the numerator. So 0 by 1, 1 minus tan inverse what J section. Okay, the tan inverse means if something A plus JB, so it should be tan inverse B by A. So that same thing I am doing. Then we can write tan inverse omega 4 RC minus 1 by omega RC, okay, by 5. Okay, so it should be 10 inverse omega RC, and this will be 0, means 10 inverse okay, 10 inverse omega 4 times of RC minus 1. This one is our what we can say, the value of y or b by x equals to 0 degree. Okay, so this value will be 0. So tan inverse, from here we can write directly 1 plus r1 by r2, the term, internal term, into 1 by 5, 1 by 5 into 1 by 5 equals to 1. Okay, means we have written the tan inverse, this term equals to 0. So it should be our 1 by 5. Just make 1 plus r1 by r2, the modulus, by modulus by, or we can say simply, or if we are getting some confusion, again I am writing the same thing here. If a beta will be 1, okay, a beta will be 1, so we can write directly, no need to go for that one. 1 plus r1 by r2, then the modulus, so the upper section will be 1. Then if we put the condition of oscillation, that is the angle part, that is our 0, so 1 by simplify equals to 1 plus, it should be 1. Okay, means this magnitude of this one, the magnitude of this one, by keeping omega equals to 1 by 2 RC, it will give 1. So 1 by 5. So 1 plus R1 by R2 equals to, hmm, it should be 5 will come here. Okay. Then R1 by R2 equals to 4. So R1 equals to 4 R2. Okay. Because the angle part we have already used. The means the for the angle part, then the here we have used a b beta, or a beta equals to 1 part, by keeping omega equals to 1 by 2 RC. So this one is our condition of oscillation, COF, okay, and this one is a FOF, frequency of oscillation. In this case we have used the angle part, so that's why we are just putting the imaginary part to 0. So the frequency of oscillation omega 1 by 2 RC, and the R1 value 4 R2. Okay, that part, and the angle A beta 0. So if we make it to, means angle portion, or equating the real part, better to, oh sorry, equating the imaginary part to 0 will give the frequency of oscillation. So this is all about this question. So our option for this question, the, what we can say, the frequency of oscillation is our 1 by 2 RC. So 1 by 2 RC is there in option C and D, and condition R1 equals to 4 times of R2. So this one is the correct answer for this question. So mainly we have to take care of this portion first, Z1, and this one. Then we have to modify the circuit, okay, as Z1, Z2. Okay, then we have to find the beta in terms of Z1, Z2. Okay, then A we have to find. Okay, then we have to just multiply both A beta and we have to solve the value of a beta. And then after, if we equate the imaginary part to 0, equate the imaginary part to 0, it will give the frequency of oscillation. Then if the magnitude, we have to take 1 by keeping the value of omega. In this case, it will give 1 by 5 into 1 plus r1 by r2. It will give the condition of oscillation. So this is all about this question. So I hope it will helpful to you. So thank you for watching this video.